Here we go, question 3. Implicit differentiation. It's a very large B, yeah. The equation of the curve C is x plus 3 times y plus 4 equals x squared plus y squared. Find dy by dx in terms of x and y. Right, well, what can we do? We've got a couple of choices with this. We could think we feel a bit scared by these brackets here, so we'll multiply out the brackets and then do that. Or we could just do it with the brackets in there, because brackets don't scare us. It's just two things multiplied together, so we can treat it as a product rule. So if you want to try it, multiplying out the brackets first and then doing it, then go for it. I'm going to leave them as they are and just differentiate every term. I'm being really careful about this. I'm going to write what I'm doing. I'm going to differentiate this first term with respect to x equals the derivative of x squared with respect to x plus the derivative of y squared with respect to x. So differentiating everything with respect to x. Here we have two things multiplied together. So it's the first times the derivative of the second. Now if I differentiate y plus 4 with respect to x, I would get dy by dx plus 0 actually, wouldn't I, if I differentiate 4 with respect to x, plus the second, which is y plus 4, times the derivative of the first. And if I differentiate x plus 3, I get 1. So that's the left-hand side sorted out. I've now got the derivative of x squared, which is just 2x. And to differentiate y squared with respect to x, I'm going to differentiate it with respect to y, and then multiply by dy by dx. 2y dy by dx. Okay? Again, this is one of the things with core form, isn't it? It's so easy to make a mistake from simplifying things and moving things around. So we're going to be really careful. Let's bring all the dy by dx kind of things over to this side. We've got x plus 3 times dy by dx. Take away 2y dy by dx. And here we've got 2x. Take away y plus 4. Which gives me dy by dx times x plus 3 minus 2y is 2x minus y minus 4. And so, finally, we've got that. And if you rearranged it slightly differently, you may have the negative of the top over the negative of the bottom. But that's fine. It's the same thing. There we go. And that was quite a few marks, wasn't it? 4 marks just for finding dy by dx in terms of x and y. Right. The line 2y equals x plus 3 meets C at 2 points. What can be said about the tangents to C at these points? Justify your answer. Well, can we spot anything that links 2y equals x plus 3 with what you've got? What we're hoping that we'll notice here is that the denominator here, if 2y equals x plus 3, then the denominator is 0, isn't it? So if when that meets this curve, makes the denominator of dy by dx 0. I don't want to write equals 0 because that implies that we've got horizontal stationary point in there. So what did we just say? If dy by dx, if the denominator is 0, then that would mean that dx by dy would be 0, wouldn't it? And we remember we just talked about this, if dx by dy is 0, that means we have vertical tangent to the curve. So we've got, so the tangents would be vertical lines. Remember what this was saying? It was saying that it wasn't saying 2y equals x plus 3 was a tangent. It was saying that meets at 2 points. What can you say about the tangents of those 2 points? Okay, just 2 marks for that. Find the equation of the tangent at the point 6, 0. Giving your answers in the form ax plus by equals c, where a, b and c are integers. Right. At the point 6, 0, well, we need to know what the gradient is at that point, don't we? So that we can do something with it. So at the point 6, 0, dy by dx is, subbing things into here, 2 times 6 minus 0 minus 4 over 6 plus 3 minus twice 0, which is, what is that? Is that 8 and 9? Bottom. We're after the tangent at that point. So this is where we go back to everything that we've done before to core 1, where you had to find equations of tangents. To find the equation of a tangent, you need the x and the y values and the gradient. So we're going to use y minus y1 is m x minus x1. Remember being careful about the language here. Some of my lower 6 students this year seem to have got into a habit of always finding the negative reciprocal, because that's one of the tricks that we pull. That's if we were finding the normal to the curve, isn't it? If we find the negative reciprocal to get the perpendicular gradient. We're just doing the tangent, so we want that gradient. We had to have it with all integer coefficients, I think we did. So we'll multiply by 9. So 9y is 8x minus 48. And so, how did they want it? Ax plus by equals c. So, what could we say? 8x minus 9y is 48. And that would be in the format that they were after. Minus 8x plus 9y equals minus 48 is just as worthy of the marks, not quite as elegant. There we go, we've just got 8 marks for doing that. It's all for the toggle, and that's maths.